Good morning, guys. Today we are back with another problem, and today's problem is a very simple problem. It's a problem which is basically the representation of a number in a binary format. So you can see that we are given a string and we have to convert the string to do binary representation, and we have to add +1 to that particular string and then return its binary representation. So for example, we have a string as 1 and 0. When we add +1, the output, like we can see the binary representation of 10, which is 2, and the binary representation of 3. So first what we have to do is, first we are taking the string. Okay, in the string we will be having 2 digits which are in binary format, and now we are like we have to check the representation. So the representation of 10 is 2, and then the binary representation of 3 is 11. So what we can figure out, that we have to return +1 with the present value. Similarly, you can see in the next example that we have been given a string s equals to 111 and the output as 1000. So what you can see is 111 is the binary representation of 7, and when we add 7 plus 1, it becomes 8, and you can see the binary representation back is a 1000, right? So like this. So first what we have to basically do is we have to check, first we have to take a string input, right? So string, we have to take a string input. So say this string contains a particular input as 10. Okay, so what we have to do is we have to first convert this 10 into a representation. So the string to binary representation, the string will become 2. So now we have to add, just let me check. So the first string was 10, okay, 1 and 0. So then we have to add 1 to this particular number. So when adding 1, this number will become 3, and then the representation back, we have to again convert it back to its original state. This will become 11. Okay, similarly, what we can see is in our next example, s equals to say 111 most probably. So the next, yeah, 111. So what we can see is 111 is the representation of the digit 7. Okay, make sure to take this in string format. If 111 is the representation of digit 7. So now when you get digit 7, what you can do is you can add 1 to this digit 7 and it becomes 8, and this particular 8 is the representation of the number 1000. So you have to return this particular number. So these are the two representations we have discussed, and what you can see is we have been given, in Python you can do it in very easy manner. What you can see is we have to take a string in our function, and then the function has to be converted the string to an integer. We have to increase the count of that integer by 1, and lastly we are just going to call this function bin of n. So bin of n is to 2. So this, what is does this is to 2 does over here. So whenever you're converting something to binary format, so in Python the representation will come like this: 00b 11200b, like this. So but you don't want to have this particular b, right? You don't want to have this leading 0. So you are using this 2 as slicing operation in order to remove the previous values. So you can just get 11 or 110 or whatever you want. So that was today's POTD. You can see that we have taken a def binary next number is the name of the function. We have taken a string in the parameter. Now we are using n over here. Then we are using the integer typecasting of 2. So we are converting this binary string to basically an integer. And then we are storing the value as over here is n. So basically the thing which you saw in that second example as 7 is stored over here. Now we are doing n plus 1 equals, so basically 7 will become 8 over here in this step. And lastly, we are going to return back to its original state. So binary representation of 8. So 8 is in what number? So in this, so you have to convert this integer number to binary number. That's why you're using bin of 8. And we are using 2 and the symbol over here for slicing operations. Okay, so let's submit the solution. So I hope this was an easier problem, and in Python there are more such available methods and libraries you can see, which helps you convert easily from binary to decimal to hexadecimal and octal number and so on. Thank you for watching this video, and we are looking forward to solve more problems.